Hello, everybody. I just would like to go through a solution of the question 41 in algebra section. Math1151 is the course, and that's the University of New South Wales. In this question, we have A, B, C. These are the countries trading each other. Each country's total income comes from the trading with others and nothing else. So A spends 3/4, 1/8, 1/8 of the income of goods from the countries A, B, C respectively, and B spends 1/5, 3/5, 1/5 of the income goods from A, B, C respectively, and C spends 1/4, 1/4, 1/2 of the income goods from A, B, C, from the country A, B, C respectively. Now, we would like to find relative income for each country. And our aim is to practice the linear system of equations. And this is an application of linear system of equations. So this is the given to us, and we would like to use this knowledge, this input, and we would like to construct first linear system of equations. So the first sentence says that A spends this times A plus 1/8 times B plus 1/8 times C. So this gives us this equation, 8 3/4A, 1/8 B, 1/8 C. So there's an 8. We can make a common factor, common denominator on the right-hand side is 8, and multiply everything by 8. Then we will be able to find out, we need to multiply this by 2, that will be 6. That's 1, and then multiply through by 8. We will have 8A, 6B plus B plus C. And the B will be, from this sentence, this will be 1/5A, 3/5B, and 1/5C. And similarly, we would like the common denominator is 5, and multiplying by everything by 5, we will obtain this one. And C is similarly 1/4A, 1/4B, 1/2C. And common denominator, we can make it 4, and this will be 2/4. Multiply everything by 4, we will obtain these equations, 4C plus A plus B plus 2C. So what we have is that this vector here is the relative income for each country, is this vector. Now we have 3 equations and 3 unknowns, and we would like to make these equations looks like a linear system of equations, like the coefficient matrix times the unknown vectors is equal to the 0, right? Because we don't have any constant term in the equation. So from here, from the first row, we have minus 2A, B plus C is equal to 0. From this equation, we have 5 minus 2B plus C is equal to 0. From here, we have A plus B. Here goes, this one goes to the other side. That will be minus 2C. Minus 2 is equal to 0. This is linear system of equations, can be written as a matrix multiplications and vectors. And this is the coefficient matrix, as we've done before. This minus 2, 1, 1, 1, minus 2, 1, 1, 1, minus 2. And the unknown vectors A, B, C, on the right-hand side is 0. This is just a matrix multiplication. This row with this column will give us this. And that is exactly the first equation, like minus 2A plus B plus C is equal to 0. So the multiplication of this row with this column is equal to 0 is the first equation, and so on. We know that this, looking at this linear system of equation, is equivalent to look at this matrix multiplication. We would like to do this because we will be able to systematically solve the linear system of equations. And also, this is a way that we can put those information to the computer, and we can ask for computer help to solve the questions for us. So since the right-hand side of this equation is 0, then this is the homogeneous linear system of equations. This is the name of it. If your right-hand side is the vector 0 vector, then the system is called homogeneous linear system of equation. And this is solvable if and only if the determinant is equal to 0. This is a criteria. I'm not going to follow this fact, but I would like to remind you. This is an important fact. If your linear system of equation is homogeneous, then it is solvable if and only if the determinant of the coefficient matrix is 0. This is a well-known fact. Please remind yourself. To find the solutions, we would like to obtain the augmented matrix, but the augmented matrix on the right column will be 0, 0, 0. We just can omit it. So the augmented matrix for this system will be just M. And then we will apply the row operations to find out the reduced row echelon form that will give us the solution or a solution. So we want the first position. This position is 1. This is not the case. So if I change this with respect to this, or you can change in this one, it doesn't matter, whatever you like. I change this row with the first row. So row 1 and row 3, interchanging. That's what I've done. So this is 1. This is perfectly good for me because there's a leading coefficient is 1. And then I want this position is 0 and this position 0. And I'm focusing on those positions. What are the row operations that make this one is 0, this one is 0? In order to be able to want this one is 0, I do row 2 minus row 1. I want to make this position is 0, then I will add this one to here by multiplying 2. So this is what it is. R3 is equal to R3 plus 2R1. Then I have this position 0, this position 0, and I need to calculate the others. So this here just a minus, so that will be minus 3. That is minus times 2 minus 2 will be plus 2. And you have 1 here, that will be plus 3. That's a plus 3 here. So that is covering this row operation. Now I'm going to do this row operation. So I'm multiplying this row by 2 and adding the last row. So that's 0. 2 times 2 plus 1 is 3. Minus 2 times 2 is minus 4. Plus 1 is minus 3. So I have, I can make this row is 1, 1, and this row minus 1, 1, or 1 minus 1. But this is we can just add this one to here, add this one to here, that I will have 0 to here. So add here, 0, 0, and divide the second row with minus 1 over 3. Then I will obtain this matrix. I would like to have, so you can stop from here, you can go back to your, because you have the leading coefficient 1, leading coefficient 1, and you can go back to your presentations of the equations from here, or you can keep going to reduced row echelon form. Personally, I prefer to keep going because it is easier actually, and it is much more clear. I can see the results in the end much more clearly. I want this position is 0 because I can do it. You know, I can make this position 0. I don't care this part anymore because this is 0, so I have a free variable there. I can make this one is 0, so why not? Let's do that position is 0. If I do row 2 minus row 1 is equal to row 1 minus row 2, I will make this position 0. That will be minus times minus will be plus 1. Minus 2 plus 1 will be minus 1. So I have minus 1 here. As we see, we have the unknown matrix was A, B, C. So the C, this is this column, we don't have a leading coefficient. So this last row says that the 0 is equal to 0. We don't have a contradiction as well. So we have a solution. And since we have a free variable here, since we don't have 1 here, if there is a 1 in this situation, it means we will have no solution. Because on the right-hand side, we have a 0 vector, right? If we have everything, if this row gives us something different from 0, it is equal to 0, it will be contradiction, and that means that we have no solution, right? So So we have a free variable, which corresponds to the column, the last column, that is C. C is a free variable. I'm saying C is equal to lambda. Lambda is in a real number. So this is an infinite solution. We have infinite solution. The first row means A minus C is equal to 0, or A minus lambda is equal to 0. So A is equal to lambda. This row implies that B minus C is equal to 0. In another way, B minus lambda is equal to 0, so B is equal to lambda. So all we have, A, B, C, is lambda, lambda, lambda. So A, B, C is lambda times 1, 1, 1 is the solution space for this homogeneous equation system. If you look at the relative income, that will be A5 lambda, and ABC is just 1, 1, 1, and lambda is any real number, we will obtain as a solution 8, 5, 4 vector. It is a relative income situation, but this is the solution for ABC. Yeah, I hope this is just the application of the application of the linear system of equations. Hopefully it is helpful for you. Thank you very much.